Hello everyone and welcome back to Stir the Coco. If you're new here, bienvenidos. That is welcome in Spanish. I'm your host, Posh Teacher. Our show is about anything and everything that makes your coco, your brain, feel fantabulous. Follow us on YouTube on Stir the Coco with myself, Posh Teacher, and here at BCTV. Before we begin, I would like to give an hola shout out to Heather, who is the queen of Spanish vocabulary. Keep on learning, Heather. Today, we are calling our show Beyond the Brain Scan, Real Talk on Brain Health and Equity. Dr. Best from the University of Michigan Neuroscience Institute will join us. We are jumping right into our Spanish lesson to create some neuroplasticity before we go off to our interview. We are going to learn reactionary Spanish idioms because we are going to hear amazing research from Dr. Best. Número uno, number one. That's crazy. Es una locura. Es una locura. One more time. Es una locura. Número dos, number two. This changes everything. Esto cambia todo. Esto cambia todo. One more time. This changes everything. Esto cambia todo. Número tres, number three. How did this happen? ¿Cómo pasó eso? ¿Cómo pasó eso? One more time. ¿Cómo pasó eso? You did great. Remember, language mastery requires constant repetition, so go try these new babies out. Well, we're off to our interview with Dr. Best.
Even the mighty might not see it coming. It's prediabetes, and it captures 1 in 3 adults. But you can escape. Take the 1-minute prediabetes risk test to know where you stand and prevent or delay type 2 diabetes. Be your own hero on smartphones everywhere at doihaveprediabetes.org.
Welcome everyone to Stir the Coco. We have a very special guest today. We have Dr. Best, and Dr. Best has a BS in neuroscience, an MS in biological and physical sciences, and a PhD in pharmacology. Welcome to our show, Dr. Best.
Thank you so much.
Well, first of all, your journey into neuroscience began real early, since middle school.
That's correct.
So can you share with us how this journey began?
Yeah, so I claim Richmond as my hometown, even though I was born in New York, technically. So there was a program called Math and Science Investigators, and they would bus local middle and high school students to a college. So at 13, even actually before then, because I started the program when I was probably 11 or 12, 6th grade, I was going to college every summer. And the goal of the program was to expose us to the content that we would receive next year. So when I was in 6th grade, they were exposing me to 7th grade math and science.
Wow.
But I was already double advanced in math and science. So they ran out of classes for me to take.
Oh!
Yes.
Wait, let's take a moment.
So they decided, hey, we'll let you go with the high school students and work in a research lab, and then we'll pay you $500. At that time,
500 like $1 million.
Yes.
Yeah.
So at 13, I was in a research lab working with fruit fly's eye as a model for the human brain.
We're speechless.
Yeah.
Wow. Okay. So, and obviously then you were fascinated by this. I mean, age 13.
Yes. And then I had a personal experience noticing the signs of dementia in my maternal grandmother. So one of the first signs was that she kept saying, there's hair growing in my throat. And then she would also not call us by our names anymore. She would just call us Sissy. Sissy.
Oh.
And so those signs, and then I'm like studying the fly's eye as a model of a degenerating brain and like seeing that in real time with my grandmother. So I was sold on neuroscience. I was like, I got to figure this out.
Oh my gosh. And boy, have you been figuring this out, because you've been studying something really interesting, the tau oligomers.
Yes.
And can you explain to our viewers what that is and how that is affecting, Alzheimer's disease and Parkinson's? Tell us about that. Fascinating.
Yeah, so tau is this thing that scientists call protein. So it's not the same as like chicken and beef protein, but it's this thing that makes up our brain cells. And it's in a special part of the brain cell called the axon. So if I could just do a demonstration, my hand is a brain cell.
Okay.
So the axon is this arm area. So all of our brain cells have tau. Tau is good. So I hate when I hear people say tau is bad. No, tau is good in its right place and its right form.
Okay.
So tau is helping to maintain the structure and the function of our brain cells. But about 10 to 20 years before someone develops Alzheimer's or other diseases that are related to tau dysfunction, the tau goes from where my arm is to where my hands and fingers. That's called the soma and the dendrites. So tau accumulating in the soma and the dendrite in the form of these sticky tangles, that is one of the signs that when we look at a brain from someone who donates their brain after they pass away, that's what we see in their brains, and we're like, oh, they may have had Alzheimer's or some other tau-associated disease.
Oh,
yes.
Okay.
Yes. So tau in its normal form is called the monomer form. So it's just like one tau protein by itself. So the tau monomers are in the axon doing what they need to do to maintain that structure and function of the brain cell. But when tau monomers start to clump together, they form these things called tau oligomers.
Wow.
And those oligomers, the lab that I did my PhD training in, Dr. George Bloom, we actually believe that the tau oligomers are actually causing the death and damage of brain cells. And we need to figure out ways to stop that from happening.
Yes, how do you stop that, Dr.
We're
Buzz?
still working on it. We're still working on it. Give us some time. And then these tau oligomers, you think they can't even get any bigger?
Yes.
They clump together and form those tangles that we see in the brain tissue at the time of death. Wow. So we believe that, some of these therapies that we're trying to figure out how to clean up those tangles may be a little too late. And we really need to start focusing on those oligomers that are actually causing damage to the brain cells.
Yeah. And is that where you're working right now?
That's what I did my PhD training in. Yes. And what I did find is that, so we talk about the axon, we talk about the soma and the dendrites, but there's this region in between called the axon initial segment. Okay. And what I found was that the tau oligomers are actually damaging that region called the axon initial segment, leading it to it getting shorter and the intensity of it diminishing. And that actually, I believe, is leading from the tau to accumulate from the axon to the soma and dendrites. So it's almost like this barrier or this fence, right?
Yes.
And so I'm thinking it's getting broken down somehow, and that is allowing that tau accumulation that we know is related to Alzheimer's and other diseases. So the key would be to figure out a way to stabilize that axon initial segment. And that's something I do want to continue to work on as I continue in my journey.
Yeah, we need to so badly. Wow, amazing. So with all this research, you used 3D technology and certain machine learning in your research. How is all that helping with researching neurodegenerative diseases?
Yes, that's an excellent question. So for me, those have been kind of something new I developed during my postdoctoral training right now at the University of Michigan. And I plan to continue to develop these skills in my second postdoc at Boston University that's coming up. So with this 3D, a lot of my work as a grad student was in 2D. We had these brain cells from mice, and we were growing them on a single level. And that was good. That was good information. We understood the fundamental pathology of how are these brain cells working. Yeah. But if we think about our human brains, they're 3D structures, right?
Yes.
So to create a better model of the brain, that's what really prompted me to move to these 3D structures. In the lab that I'm in now with Henry Paulson at the University of Michigan, we call them the 3D brain organoids.
Oh,
and so that's a fun word.
Yes.
But essentially, it's a bunch of cells that are actually from humans. So we can take skin samples from a human. Right now, I'm working with samples from healthy donors, but my ultimate goal at Boston is to actually work with samples from people who had Alzheimer's, who had other neurodegenerative diseases, and see if we can really replicate what's going on in the adult brain. But essentially, we take these skin samples, and you can also take blood samples, and then you turn them into these things called stem cells, which have the ability to become any cell in the human body, any organ system. And then, of course, we're telling these stem cells to become brains, right? So we give them different inhibitors and growth factors to facilitate the development of brain cells, and they form in this spherical structure.
They do?
Looks very similar to a human brain, and you can see that layering of the human brain, and you can do all types of fancy techniques with them. And then in terms of the machine learning, I'm actually using that with my human brain tissue work. So you say you got a chance to experience the brain bank. So
yes.
I'm able to benefit from brain banks and request human tissue samples. And I do this technique called immunofluorescent staining. So I can actually see the different brain cell structures, see the tau in real time in these brain tissues. And then, because it would be impossible for me to count every single structure by hand, I mean, it would be possible, it just take a very long time. I use this fancy technique called machine learning, and that allows me to feed in a group of images that are my like sample images, and then I tell the computer, this is a tangle, this is a brain cell. And then I can feed in my thousands of images, and the computer can go back with that information I taught it, and it can identify tangle, 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 tangle. And then I can create these beautiful graphs that says this brain had 100 tangles, this brain had 1,000 tangles, this brain had 0, and really get more sensitive information about how heterogeneous these diseases are. Because we put them in a box. We're like Alzheimer's, frontal temporal dementia.
Yes, we do. You're right.
But this person that has Alzheimer's has this amount of tangles and this tau pathology, and this person has this amount. What are the differences? What are the nuances that we can learn more about the intricacies of these diseases we're studying?
That is fascinating. Yes.
Yeah.
Oh, well, wow. I'm glad you shared that, because a lot of people don't understand how technology is used in science and in research. They just think it's petri dish in the lab.
Exactly, and that's actually how I started off. So I'm not going to discredit that. I love the bench. I love to do a good experiment, but we have to partner with other fields. I love interdisciplinary research. So it's taken me out of my comfort zone, because I didn't know how to code in R. Like, I don't know Python, but I had to collaborate with computer scientists who do that regularly, and together we're creating magic, because we have my data that I accumulated from doing those experiments, and now I'm coding, I'm typing in the terminal, so like it's really fruitful when you're open to it.
Yeah, and you know what? I think this is, I really like you sharing this, because for the younger generation, you're opening up fields and areas of interest that they might not even know about.
Yes.
And I just sense this amazing passion that you have. I hope that, other people will see that and see that there is a lot of magic and interesting things happening in science.
Yes.
And actually, you started an organization, the Brain Wealth program. And tell us about it. I think there's a lot of passion with this project.
And I did want to piggyback off of what you said about getting the kids interested.
Yes, please.
Because that's kind of how I started with my outreach. So it's very rare, or at least I haven't seen a lot of models of scientists like going out into communities.
Yes.
And that has been something that it pulls on my heartstrings because I always felt it's not enough for me to be this cool scientist. Like, I want other kids to know, like, that is a possibility for them too.
Yes.
And especially like other underrepresented kids, like the Black kids and the girls, you know, I want them to feel empowered that, hey, you can be a scientist. And in fact, you already are a scientist. Like, the questions you ask, the curiosity that you have, those are instrumental qualities of a scientist. So I make these little activity kits called STEAM kits that really blend all the fields and encourage students to do science projects at home or in their community groups, different things like that. And then I felt like with that work, super passionate about it, but I felt like I needed to figure out an outreach for older adults as well. So that's why I made Building Brain Wealth. And it was actually a part of a fellowship that I won. So I'm a part of the Black Men's Brain Health Conference Emerging Scholars Program. And what they do with that is they see this gap in the literature that Black men are underrepresented in Alzheimer's research. And also because of the high rates of Black men in NFL and football, they're more susceptible for Alzheimer's. And have you heard of chronic traumatic encephalopathy, CTE?
CTE,
yes.
That one.
Yes, that one.
Not the big one. Yes.
And so we know that there's this predisposition. So more research needs to be focused on why is that happening, right?
Yes.
So the Black Men's Brain Health Conference, it was started by Dr. Robert Turner and a group of other scientists and researchers, and it's an annual event. So I attended it this past year and was in New Orleans. They try to do it around the Super Bowl time.
Oh, I was going to say, that's what the Super Bowl is.
Yes, and as a part of that, they challenged us, do something in your community to promote men's brain health. And so that's why I started Building Brain Wealth. And BRAIN actually is an acronym.
Yes, tell us what it stands for. Yes.
So it's Brotherhood, Resilience, and Insight through Neuroscience.
Wow.
Yes, so super powerful because it's a platform to provide educational resources, a platform to provide open conversations and dialogue about some of the unique issues that Black men in particular face, and giving them that safe and brave space to have those conversations. And then we also bring in like experts. So we had someone talk about spiritual and social health, mental and emotional health, occupational and financial health, and then we ended the day with our physical and environmental health. And we actually had a personal trainer.
Program.
Yeah, he was out there having us do exercises throughout his
that's
workshop.
Good for the brain.
Yes, definitely. And all in all, it was our first event, but we're going to do it every year now to continue to cultivate this community, but also have those conversations to promote proactive health management.
Yes, you talk about that, proactive health management. Well, so spreading that proactive health management, from your scientist perspective, what are top things that people can do to, habits they can form to help with their brain health management? Because
unfortunately,
you have the inside scoop.
I do, but it's all things we know we should do, and we just don't have the discipline to. So, and it's even as a scientist who does this research, getting enough sleep. We already know that.
We do, and I see that in the high school.
Yes,
we should start later. These kids don't get enough, so how can they think?
Yeah. Or honestly, it might be that blue light from the phones that's keeping us up at night. So one of the things I've challenged myself to do is actually leave my phone in a different room that I go to sleep in. So that would just, I don't have the discipline to stop scrolling, so I just put it away. And maybe do that about an hour before you want to wind down. The other thing is eating right. We already know that we should be eating right. But unfortunately, some of the things that we're calling food these days is not real food. So really going back, I'm a believer, so I always say go back to God's foods, like those healthy, foods, and in their natural state too. Like rather than drinking that apple juice, go ahead and eat an apple.
Keep it simple.
Yes. And then the other thing is what we already know. Exercise, right? So I recently turned 30, and so the first thing I did was get a gym membership because there is like scientific data that shows like your health outcomes diminish if you are not regularly exercising at the age of 30, by the age of 30.
No.
Yeah, it's like a line graph, and then it's like the age on the x-axis, and then health outcomes on the y-axis, and then at 30, it's like this huge, like, yeah.
What? So that's it. Like every day you need to exercise.
Yeah,
like,
they do recommend about 30 minutes of active, and that could just be a simple walk.
Okay.
But it's just like the consistency of moving your body. For me, I do have an Apple Watch that reminds me, hey, you need to stand up. You've been sitting down too long. So different things like that to just get moving.
They can help you.
And doing what we know we should do anyway.
I know. How about hydration? Is water good for the brain?
Water's just good for the body in general.
Okay.
We are made up of water, so
Yes.
I think most people are dehydrated because by the time you get thirsty,
Yes.
you're already dehydrated.
Right.
So just having that regular water, I think the estimate, and it's different for men and women from what I remember, but I think the
that's
average
good
is
to
like what, 8 cups or 8-ounce cups.
Yeah,
a
so
day.
64 ounces. Or
Something like that.
Yeah, it's a good
I feel
size
like
water bottle.
You're never having enough water, so
Yes.
drink more.
So all these things can, speaking of prevention with Alzheimer's and dementia, people get concerned and they don't want to be at that stage where their toes all tangled.
Yeah.
Are there things that are, that we can do at any stage to help our brain stay fit and healthy?
That's the million-dollar question, I
Yeah.
feel. A lot of times, as a scientist, I
Yes.
think it is a time where it's too late, unfortunately,
Yes.
because it's like, these are the brain cells likely that you were born with, right? So
Yes.
they have been essentially aging that whole time. And then from what we know with the tau oligomer information is that it's happening about 10 to 20 years before any signs of dementia starts.
Okay.
So likely, if we're going to really see a preventative or that cure that we're looking for, we're probably going to need to initiate treatment much earlier.
Good.
And then more targeted treatment, right? Because I was saying, maybe this person has 10 tangles and this person has 100 tangles. The treatment that each of those people get probably should be customized. So you probably heard of the term personalized medicine.
Yes,
I think
yes,
that's
that's
really
amazing.
where we're going to have to move closer
wonderful.
towards, and probably earlier. So most people with the sporadic form of Alzheimer's get it later in life. So maybe in the 30, 40 range.
So maybe walking,
Yeah.
doing all those healthy habits.
And then those healthy habits honestly should start as a child.
You know what? Tell me, even learning is a healthy
Yeah.
habit, because
Yes.
Dr. Bez, you told me, it's fascinating how intelligent you are, and you tell me what you were saying. Where did your learning start happening?
Oh, yes. So
I think that's
I am one of 5 actually, but most of my childhood I was just one of 2. And so I have a brother that's about 5 years older than me. So when I was a very young child, I'm trying to do his homeschool work because my mom homeschooled him because we were living in New York at the time.
Okay.
And my mom just really wanted to ensure that she was giving him the best educational opportunity she could. And she has an education background, so I'm like barely able to talk, but trying to do his homeschool assignments and his work, following him around. So that early love and exposure and curiosity for education, I think that's what persisted throughout my life, because I basically didn't stop school until very recently. I got my undergrad.
Yes.
I never stopped.
You
I
never stopped learning,
Yeah.
which is something we should all do.
Yes.
Never stop learning.
Lifelong learners, what I say.
So, well, this has been amazing to have you and to really dig deep into the world of science. And now I'm going to grab my apple, my Manzana, and ask you a question.
Okay.
Oh, excuse me. So I'm going to add more to our neuroplasticity.
All right.
And this is a surprise question
Okay.
for La Manzana, and then we'll teach you a little phrase in Spanish.
I
because
appreciate it.
You can't leave Stir the Coco without a little Spanish.
I love it.
So, so here we go. Dr. Best, what is your favorite brain fact to drop at parties? Yeah,
Yeah, you do have me thinking.
Good.
I will say the brain is so powerful.
Yes.
And this is not like a fact or anything.
Yeah,
it's just
but
like, I guess what I will say is like, we've been studying Alzheimer's, for example, since 1906.
Wow.
Yes. And I guess the fun fact with that is that one of the key scientists that has helped with the discovery of the tangles was an African-American man named Solomon Fuller. Yeah. And oftentimes we credit everything to Alzheimer's, and the disease is also named after him. But I guess like that's the fun fact is like there's some unsung heroes in the Alzheimer's field that really deserve a little bit more celebration.
So this word is perfect for that. The word is super cool in Spanish. So here we go. Hang on. Padrísimo.
Padrísimo.
Good. Try one more time. Padrísimo.
Padrísimo.
Muy bien, doctora. So that means super cool. Padrísimo. And I can give you the card and you can take it with you. And you can
Thank you. Yeah.
Well, thank you so much. And we really appreciate, you sharing your story, and hopefully it'll motivate others to
That's my goal.
Really, yes, to really dig into science or research or just taking care of their health. So, okay, well, thank you so much. Gracias. Adiós. Adiós.